All right, kids, let's do 35B. It says we have an unbalanced equation, so we're going to have to balance it. We have 50 grams of each reactant for any of these, and we want to see which one's the limiting reagent, and then what's the mass of the product, which is, in this case, for B, is BaSO4. So basically what we're going to do is we're going to convert both of these to grams. Whichever one is the least amount of grams is going to be our limiting reagent, and that's going to be our answer for BaSO4. So we're going to convert both of these. So we're going to convert both of these to BaSO4. Let's do it now. Okay, first let's balance this equation. We have 1 barium. We have 2 chlorines. We have 2 sodiums. And we have 1 sulfate. Over here we have 1 barium. We have 1 chlorine. We have 1 sodium and 1 SO4. So it looks like we just need to put a 2 here. That's going to give us 2 chlorines and 2 sodiums, and we're balanced. So we have a mole ratio of 1, 1, 1, 2. But we're not even concerned about this one because we're trying to convert to this. So our mole ratio for both is going to be 1-to-1 ratio. So that should be pretty easy. We're going to convert both of these. The problem said that we have 50 grams of it, so of both. So let's start with 50 grams of barium chloride, and let's down here put 50 grams of sodium sulfate. Convert them both to grams, to moles. It's going to be 1 mole, 1 mole, and put it in the substance. And then we're going to go to our periodic table and come up with the molar mass of both of these. Okay, so I calculated all the molar masses. I did barium chloride here. I still need to add up the sodium sulfate here. But I did make note that a sulfate ion is 96.1. I knew I was going to have to do barium sulfate because that's going to be our where we're heading. We're going to have to find the we're going to have to convert to barium sulfate, grams of barium sulfate ultimately for both of these. So I took the liberty of doing that. And I'm going to add this up while I'm over here. So now we have all the molar masses we need. Let's convert this one. Now we have we got moles of barium chloride. We got to go to moles of barium sulfate, and it's a 1-to-1 ratio. And then we got to go to grams of barium sulfate, which is 233.4 grams per 1 mole of barium sulfate. And then same conversion factor here. Except a different substance, because it's a 1-to-1 ratio here. And same mass. And then we're going to just put it in our calculator. Except I forgot to put my grams in here. So barium chloride was 208.3. And sodium sulfate was 142.1. Can you already tell which one's going to be the limiting reagent? It's going to be the smaller one. This number's the same. This number's the same for both. This number's bigger than this number. And these numbers are the same. So in this particular case, we just have to see, we see that this is going to divide by a bigger number. So barium chloride is going to be our limiting reagent, but let's carry out the math. All right, let's do the first one. 50 times, come on, 50, come on, 50 times 233.4 equals, divided by 208.3, and we get 56 grams, 0.0 grams of BaSO4. How do I know that's the unit? Because cancels out, cancels out, cancels out, cancels out, cancels out, cancels out. I'm left with grams of BaSO4. And on this one, I'm going to have 50, doing this one, 50 times 233.4. See, it's the same number, but it's divided by a smaller number, 142.1, and I get about 82.2. Not that it matters, because that is not our limiting reagent. We're not going to be able to make this much of it. We are only going to make the least amount. So BaCl2 is our limiting reagent. This is our answer, and our limiting reagent is BaCl2. That's our answer for 35B. Now we're going to do 36B. And this one doesn't give us grams, it gives us milligrams of each reactant. And this one we're doing aluminum and iodine, make aluminum iodide. We're going to show the calculation which is limiting and calculate the mass of each product. So we're basically going to do what we did last time, except we're going to start with milligrams. We have one more conversion to do. Okay, I started out by calculating the molar masses of aluminum, iodine, and aluminum iodide. And we have a skeleton equation, so we have to balance it. I see that iodine and iodide over here are 2 and 3, so I need the least common multiple, which is 6. So I put 2 and 2, then I have 2 aluminums, so I'm balanced here with 2, 3, 2. We're starting with milligrams. We need to go to grams. We know that there's 1,000 milligrams of aluminum in 1 gram of aluminum. Same is true here. Milligrams a milligram. Now we got to convert to moles. I'm going to put grams on the bottom of aluminum. I'm going to put moles of aluminum on the top. It's going to be 1 always on these grams to moles, always 1 mole. My molar mass is 27, so I'm going to put 27.0 down there. Now I'm going to convert to our product, to our unknown, which is aluminum iodide. There's 2 moles of aluminum iodide for every 2 moles of aluminum, which is easy on this one. We're going to cancel those out. And now we're going to convert. I didn't put moles in, did I? And now I'm going to convert to grams. I know for every 1 mole, again, whenever it's grams per mole, it's always 1 mole. The only time it's not 1 mole is on these mole ratios. It could be 1 mole, but it could be something else too. 1 mole of aluminum iodide for every, I already did it down here, 407.7 grams of aluminum iodide. And I cancel out milligrams of aluminum, milligrams of aluminum, grams of aluminum, grams of aluminum, moles of aluminum, moles of aluminum, moles of aluminum iodide, moles of aluminum iodide. And I'm left with grams of aluminum iodide, which is what I want. And I will total that up in a second. Let's do this one. This molar mass is different. It's 253.8 grams for every 1 mole of I2. And then I'm going to go moles to moles. There's 3 moles of I2 for every 2 moles of aluminum. The 3 moles of I2 for every 2 moles of aluminum iodide. Can you already see what's happening here? I got bigger numbers on the bottom here. Much bigger numbers. This is going to be our limiting reagent. You can already tell, because this number is going to be the same. You don't even have to do this. You could just go to moles, and I just do this because I feel like even though it's a little more work. You're going to have to do it anyway. Although since I can already tell it's this one, once I'm good at determining limiting reagent, I'm just going to do the one that's limiting reagent. I can tell it's I2, so I'm going to do that. But then we'll do it to make sure that we're right. Times 2 times 407.7 equals divided by 1,000 divided by 253.8 divided by 3, and we're going to get 0.011. No, sorry, we need 3 sig figs, so it's 107 grams of aluminum iodide here. Now the question asks for the answer in mass. It asks for the mass, so I'm good. I can keep it in grams. If it asks for milligrams, I'd have to convert one more time to milligrams. So you can see that stoichiometry can get pretty long. So let's do the top one just to make sure that we know that this is the limiting reagent. So we're going to do 10 times 2. Although, you know what? Let's cancel these 2's out so we don't have to deal with them. Let's do 10 times 407.7 equals divided by 1,000 and divided by 27. And sure enough, we get 0.151 grams of aluminum iodide. And if you compare them, the one that creates the least amount is the limiting reagent. If we had excess iodide, we could make this, but we don't. We have excess aluminum, so we can only make this. So our answer is this, and our limiting reagent is I2. So those are our answers. Okay, finally we have 37, which is basically asking us which one's going to be more effective at making iodine, chlorine gas or bromine gas. For both cases, we're going to start with 25 grams of sodium iodide and 5 grams of chlorine, 5 grams of the halogen. So 5 grams of chloride, 5 grams of bromide. Now of chlorine, and bromine. But we're going to have to figure out limiting reagents on both, because in one of them, sodium iodide might be excess, and in one of them, the halogen might be the excess. So let's do it. Okay, I personally decided to start out by finding the molar masses I knew I would need to answer these problems. Now I'm going to balance equations. 2 chlorines, 1 chlorine, I need a 2 here. That's 2 sodiums, I need a 2 here. And we're balanced. 2 sodiums, 2 iodines, 2 iodines, 2 chlorines, 2 chlorines, 2 sodiums. It's all working out. Let's balance this one. 2 bromines. I have a feeling it's going to be just the same because they're halogens and they behave the same. Okay, so we have a 1:2:1 ratio. The given for both was 25 grams of sodium iodide and 5 grams of chlorine gas. And we have the same amounts of halogen and sodium iodide down here, so let's convert them both. We have 71 grams of chlorine gas for every 1 mole of chlorine gas. Convert moles to moles. For every 1 mole of chlorine gas, there's no number there, there's 1 mole of iodide. That's easy. And then we might as well convert to grams. We have 253.8 grams of iodide for every 1 mole of iodide. The same thing down here, except we have sodium iodide, which is 149.9 grams for every 1 mole of NaI. Convert to moles of iodine. There's 2 moles of NaI for every 1 mole of I2. And this number is the same. I'm realizing now that this conversion is going to be the same as this one, so we don't really even have to do this. We're going to do this one and compare it to the grams that we get here. So let's do that one first. We have 25 times 253.8 equals, and then we divided by 149.9, and also divided by 2. And we're going to wind up with 21.2 grams of NaI if we have excess chloride, and we're not going to know until we convert this one. So let's do that one. 5 times 253.8 equals, divided by 71, and we're going to get 17.9 grams of I2. Sorry, this is I2 here. Why? Because we cancel out, 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 and we're left with grams of iodine in both. But we're only going to get the least amount. So the limiting reagent on this chlorine, we're going to get 17.9 grams on this one. All right, now let's do the bromine down here. It's going to be very much like the chlorine one, except this number is going to be different. It's going to be 159.8 grams, and everything else is the same because they're both halogens. And we cancel out, cancel out, cancel out, cancel out, cancel out, cancel out. And we do 5 times 253.8 equals, divided by 159.8, and we get only 7.94 grams of I2, which is also our limiting reagent. So in both cases, sodium iodide was the excess. Because bromine's so much heavier, we have a lot less of it with 5 grams. And so we wind up with less of I2. So the answer is we're going to wind up, the one that's going to make more is chlorine. So if I'm in the iodine business, I want to work with chlorine and not bromine. That's our answer, everybody.